Alright, now we have two theorems. Now keep in mind that we're not going to have to recite these theorems. We just need to be able to use the theorems. The first one is called the rational zeros theorem. I'm just going to tell you what all those words mean instead of reading it. And then the second one is called the complex conjugates theorem. So let's think for just a moment. Let me see if I can find a nice example for us. Let's look at that one. We're actually going to work this one in just a minute. But looking at this polynomial, do you have any idea how to factor it? I don't even know where to begin. We can't factor by grouping because it won't work. And that's pretty much the only thing we know when we have a third degree polynomial. So we have to figure out another way. Well, of all the numbers in the whole universe, the rational zeros theorem helps us shorten that list. We don't want to test every single number in the universe, right? We want to just test a small list of numbers. This is how it works. You have a polynomial, and your constant is going to be your p. Your leading coefficient is going to be your q. Okay? So if I ever say mind your p's and q's, I'm talking about your possible rational zeros. All right. So let's make a list here. P is 2, Q is 1. So this one's actually going to be pretty simple. What you want to do now is list all the factors of each one. So what multiplies to give you 2? Well, you could multiply 1 times 2. You could also multiply -1 times -2, right? So we encompass all those by just doing a plus or minus in front of the whole list. Well, numbers that give you 1 are 1 times 1 or -1 times -1. So we just need positive and -1. To make our list, we have to do all of our p's over all of our q's. Now sometimes these lists are kind of long, so your p over q list gets pretty long too. P over q is going to be plus or minus. Always do plus or minus and then make your list. We have 1 over 1, which is 1, and we have 2 over 1, which is 2. That's your list of p's and q's. Those are all the possible rational zeros. In other words, out of all the numbers in the whole universe, the only possible rational zeros are a positive 1, a -1, a positive 2, or a -2. And that's it. Okay? That's what it means to list the possible rational zeros. Now the complex conjugates theorem says that if a plus bi is a zero of your function, then a minus bi is also a zero of your function. Remember, complex means you have an imaginary part in your number. So if you have something like 2 minus 3i, and you are told that this is a zero of your function, then 2 plus 3i is also a zero of your function. You automatically know that. You don't even have to think about it. Remember, that's what conjugate means, by the way. You just changed the sign. Alright. In these next few examples, we are going to do A through F. We're going to figure out the end behavior of our graph, find all the zeros, completely factor our polynomial. We're going to find all the real and imaginary zeros. We're also going to look at their multiplicities. We're going to find the y-intercept, and we're going to sketch the function.